Last week we covered lists and dictionaries, two of the most useful data structures in Python, but everything we've built so far disappears the moment the program ends. Close the terminal and it's gone. This week, that changes. We're learning file handling, how to read data from files and write data back to them. Your programs will finally be able to save and load information. We'll cover opening files, reading content, writing and appending data, context managers, working with CSVs, and handling errors. By the end, you'll be comfortable working with files in any Python project. Let's start with the basics. To work with a file in Python, you use the open function. It takes two arguments, the file name and the mode. Take a look at hello.txt in our editor. It's a simple text file with 2 lines. Now, let's switch over to main.py and write the code to read it. We open hello.txt in read mode, which is R. We call file.read to get all the content as a single string. Then we print it, and importantly, we call file.close when we're done. There in the terminal, the contents of hello.txt printed out exactly as they appeared in the file. Always close your files. If you don't, you risk data loss or locking the file. Now, there are 4 main file modes you need to know. R is read mode. It's the default. Use it when you want to read from an existing file. W is write mode. It creates the file if it doesn't exist, or overwrites it completely if it does. A is append mode. It adds to the end of the file without touching existing content. X is create mode. It creates a new file, but fails if the file already exists. These 4 modes cover almost everything you'll need. There are several ways to read a file. Let's go through them. Here is a text file called names. This simple file contains 3 names, 1 per line. Let's look at 3 different ways to read it. The first is read. It loads the entire file into a single string. You can see in the terminal Alice, Bob, Charlie printed out. This is fine for small files, but be careful with large ones, you'll load everything into memory at once. Now, the same file again, except this time we use read lines. This reads all the lines and returns them as a list. Look at the terminal output. Notice each line still has a \n, a new line character, at the end. You'll often need to strip that off. The third and most common approach is looping through the file line by line. For line in file, we print line.strip. The stripped method removes the trailing new line and any extra whitespace. We get the same result in the terminal, but much cleaner. This is memory efficient because Python only loads 1 line at a time. For most tasks, this is the approach you'll use. To write to a file, open it in write mode using W. We open our output text file with write mode, then call file.write twice. Each call writes a string. Notice the \, with the letter N at the end. That's a new line character. Without it, everything ends up on 1 line. And if we switch over to the output text file, there it is. The content we just wrote is now saved to the file. Here's an important warning. Let's look at our output text file as it is now. It has the content we just wrote. Watch what happens when we open it again with W mode and write something different. Look at the file again now. The previous content has been completely replaced. This is because write mode overwrites everything. This catches people out, so remember it. If you open a file with W and write to it, whatever was there before is erased. If that's not what you want, you need append mode. Append mode, using A, adds data to the end of the file. The existing content stays untouched. Here we open our log text file in append mode and write 2 entries. Every time you run this program, it adds more lines. If we look at log, there are our entries. The file grows and nothing gets overwritten. This is perfect for log files, history tracking, or any situation where you want to keep adding data over time. So far, every example has followed the same pattern. Open, do something, close. But there's a better way. The with statement, also called a context manager, handles closing automatically. Here's our names text again. You write with open, then as file, and everything inside the indented block has access to the file. Once the block ends, Python closes the file for you. No need to call close. No risk of forgetting. If an error happens inside the block, the file still gets closed properly. There it is, same result as before. Here's the same thing for writing. With open W mode and as file, and write your data. When the block ends, it's done. Switch over to the output text file and you can see the content has been written. This is the recommended way to work with files in Python. From now on, every example will use with. CSV stands for comma-separated values. It's one of the most common file formats for data. Spreadsheets, databases, and APIs all use it. Let's look at our scores. CSV file. Each line has a name and a score, separated by a comma. Open the file, loop through lines, strip the white space, split on commas. Parts at index 0 is the name, parts at index 1 is the score. You can see the results in the terminal. Alice scored 85, Bob scored 92, and Charlie scored 78. This works, but it's fragile. What if a value contains a comma? Python has a built-in CSV module that handles this properly. Using the same file, we import the CSV module, open the file, create a reader with csv.reader, then loop through the rows. Each row is a list. Row at index 0 is the first column. Row at index 1 is the second. We get the same output in the terminal, but it's much more robust. For writing, use csv.writer. Open a file in write mode, create a writer, then call write row for each line of data. The first row is typically the header, in this case name and score, then each data row follows. If we look at new score's CSV file, there's our data, properly formatted. The CSV module handles quoting, escaping, and edge cases that manual splitting misses. Use it whenever you're working with CSV files. What happens if you try to read a file that doesn't exist? Python raises a file not found error and your program crashes. Not ideal. You can handle this with try and except. Wrap your file operations in a try block. If a file not found error occurs, the except block runs instead. Your program stays alive and the user gets a clear message. Here we see file not found in the terminal. Another approach is checking first. Import os module and use os.path.exists to check if the file is there before opening it. If it exists, read it. If not, handle it gracefully. Both approaches work. Try and except is more Pythonic and handles unexpected errors. Checking first is simpler to read. Use whichever fits your situation. Let's put everything together with 3 practical examples. First, a word counter. Here's a short text file called story. Now, over in main.py, we open it, read the content, split it into words and lines, then print the counts. Split with no arguments splits on whitespace and gives us words. Split on the new line character gives us lines. A simple but useful script. Second, a logging function. We define a function called logMessage that opens a file in append mode and writes the message. Then we call it 3 times. And if we look at app.log, there are our 3 entries. Every call adds a new line. This pattern is everywhere in real applications, tracking events, recording errors, keeping an activity log. Third, a CSV grade tracker. Take a look at grades.csv. We've got a header row with name, maths, science, and English, then a row for each student with their scores. Now in main.py, we open the file, create a reader, skip the header row with next, then loop through the data. For each student, we calculate their average grade and print it. In the terminal, we see Alice 88.3, Bob 91, Charlie 76.7. This combines file handling, the CSV module, loops, and some basic maths. A realistic example of how you'd process data from a spreadsheet. That's file handling in Python. You know how to open files with different modes: read, write, append, and create. You know 3 ways to read. You know how to write data and how append mode differs from write mode. You know context managers, the with statement, and why they're the recommended approach. You know how to work with CSV files using Python's CSV module. And you know how to handle errors when files don't exist. Your programs can now save and load data. That's a big step. Next week, we're building a quiz game from scratch. It'll use everything you've learned so far: variables, loops, functions, lists, dictionaries, and file handling. Your first real project. If this helped, subscribe to the channel. New tutorial every week. See you in the next one.